Your clock is designed to chime once each hour on the hour. The clock has a fault so that each time it is supposed to chime, there's a constant probability of 1 over 10 that it will not chime. Okay, so 1 over 10 it will not chime. It may be assumed that the clock never stops and that falls occur independently. The clock is started at 5 minutes past midnight on a certain day. Find the probability that the first time it does not chime is at 6 on that day. Okay, so at 6 on that day, it doesn't chime. Okay, let's fix this. Let's get this. So the probability of doesn't chime is, okay, in this question, the probability doesn't chime is 1 over 10. So that is your P. So your P is 0.1. So your Q is 0.9. Okay, bear that in mind. So the first question, P, when the probability is 6. So in this case, so 0.9 to the power of 6 minus 1 to the power of 5, 0.1, and the answer is what do I get? Okay, let's use the calculator. I didn't find the answer. So that's 0.9 to the power of 5 and then multiply by 0.1, and the answer is 0.059049. Okay, 0.059049, 0.9 to the power of 5, okay, times 0 to the power 1. Yeah, okay, that's correct. Okay, next. Okay, next B. Okay, before 6 o'clock in the morning on that day. So it doesn't chime. Okay, find the probability that the first time it does not chime is before. So P is X less than 6, before 6. So it doesn't chime before 6 o'clock. Okay, so for this, I'm going to use what if it only doesn't chime or doesn't chime before. No, it chimes. What if I write P is X is greater than or equals to 6? What does that mean? For the first part, okay, on top, when it doesn't chime before, it meaning it doesn't chime at P is X equals to 1, doesn't chime plus X equals to 2, and so on all the way up to P X equals to 5. You can find individually, or what you could do, find what if it doesn't chime for the first time after 6. Okay, after 6. So after 6 and after. So if I do that, so this is to find this probability, what you can do, okay, it doesn't, meaning it chime before that. Okay, so before it doesn't, X is greater than or equal to 6 means the first time it starts chiming is at 6 o'clock, and after that, so before that it doesn't chime. So to find out what is before that it doesn't chime, it's 0. To the power of, this is 0.9 to the power of what is that, 0.9 to the power of 5, correct? Okay, yeah, 0.9 to the power of 5. Okay, so that should be, okay, so that should be, oops, yeah, 0.059049. Okay, so the complement of this, what is the complement of this? The complement of this is, okay, P complement, if I take 1 and then minus P, X is greater than or equals to 6, then you will get what is it before that. So P is X is less than 6. Yeah, so all I have to do, once I've got this, I take 1 and then minus the probability of 0 greater than or equals to 6, which is 0.59049, and when I do that, I'm getting 0.40951. Okay, I would like to always work, the probability, finding the complement. I think I understand better. okay, because the question says what if it doesn't chime before 6 o'clock. So it doesn't chime before 6 o'clock. But my question, what I'm doing, what if it doesn't chime after 6 o'clock? Okay, if I want to find what is the probability, what if it doesn't chime after 6 and after that, then the complement of that should be it doesn't chime before, isn't it? Before 6 o'clock, which is 1 to 5. So that's what I did it here. Okay, I hope that's clear. Okay, next question 2. Okay, another clock is designed to chime twice each hour, so every half an hour in that case, okay, on the hour and 30 minutes past the hour. This clock has a fault so that each time it is supposed to chime, there's a constant probability uh, of 1 over 20 that it doesn't chime. So in this case, P is 1 over 20 or 0.05, okay, doesn't chime. So Q equals to 19 over 20, which is 0.95, right? Okay, 0.95. So let's just make sure that's correct. 1 over 20, 0.05, okay, and then 0.95. Yep, okay. So first question, find the probability that the first time it does not chime is either at 12:30 or at 1:30 in the morning. Okay, 12:30 or midnight, just 30 minutes past midnight, or 1 o'clock. So if it's 30 minutes, so P axis equals to 0030 plus P axis 0130. Okay, so these are the two things that I have to find. These are the probabilities. So for 12:30, okay, we have 19 over 20 or 0.95 to the power of 1 minus 1. Because why it's 1 minus 1? Because the first time the question says it's 5 minutes, the clock started 5 minutes past midnight. So 30 minutes is, the first 30 minutes is only after 12:30. So that's your first 30 minutes, okay, 30 minutes past the hour. So 1 minus 1, and then multiply by 1 over 20, okay. So this is same as 0.05, okay. So and then you add with for the second one, which is 19 over 20 or 0.95, and this time it's at 1:30. So 12:30, 1 o'clock, 1:30. So you already have 3. So it should be x, I mean, in other words, it's x equals to 3. So 3 minus 1, okay, and then 1 over 20, and your answer is 0.045125. So when I add these two, okay, when I add these two both, okay, when you add, the answer is 0.095125, okay. And the last one, part B. Okay, for part B, the question is use the sum of infinity, the formula sum of infinity, to get the answer. What's the formula for sum of infinity? S infinity equals to A over 1 minus R. A over 1 minus R. So you need to find what is A, what is R. Okay, that's not an issue. We can find that, not a problem. Okay, so let's say it's 30 minutes past the hour. Okay, so what is the probability? So P x equals to 1. And then you have P x equals to 2, and then you have P x equals to 3, and so on and so forth. So using that probability, so I'm going to deduce a formula. So the formula is 0.95 to the power of 0, okay, 1 minus 1, and then 0.05, and then the next one is 0.95 to the power of so the second one is after the first hour. So the second one should be at, it's always, the question says does not chime at the 30 minutes past the hour. The first time it does not chime is at 30 minutes past some hour. So 30 minutes past some hour. So it's like 1, 1:30, 2, 2:30. I mean, it's at 1:30 and then 2:30, 3:30, 4:30, and so on. So the first one is at 12:30. So, and then that's 1. So we discard 1, and then the next one is 1:30. So 1:30 you already gone to x equals to 3. So it's not x equals to 2. So it is x equals to 1, x equals to 3, x equals to 5, okay, and then x equals to 7. Okay, so that's how it is. So it should be 0 to the power of 2, 0.05, and then the next one is 0.95 to the power of 5 minus 1, which is 4, and then 0.05, and then the next one I think it's 0.95 to the power of 6 because it's 7. Okay, do you get it? Because the question says half an hour, 30 minutes past some hour. So some hour means at 1 o'clock. The next one is, it starts at 1:30. Okay, so 1:30 and then 2:30. So you missed that 2 o'clock or 3 o'clock or 1 o'clock. Okay, so I hope you get that. So from here we can deduce the A is what's common here. A is 0.05. And then what about your R? Okay, your R is let's say 0.95 to the power of 2 divided by 0.95 to the power of 0 is 0.95 to the power of 2. Does that work? So for this, 0.95 to the power of 4 divided by 0.95 to the power of 2, yes, 0.95 to the power of 2. So that's my R value. Okay, so from here we can find the summation. Okay, so S summation equals to A equals to 0.05 over 1 minus 0.95 to the power of 2, and this is same as 20 over 39, and in decimal it is 0.5128. Okay, so that's it. Let's go through with all of it. Okay, given a term, look at my answers, go through with each and every question, and if you have any trouble, please ask me later. Okay, thank you.